The Service Foundry Console is a unified interface for deploying, monitoring, and managing Kubernetes applications. It brings developers and operators together in one place, making GitOps workflows simple and collaborative. This slide illustrates how Service Foundry automatically provisions two types of Kubernetes load balancer services to securely expose the front end and back end of the console application. At the top, we see Keycloak, which handles identity and access management IAM. It provides centralized authentication and issues OAuth tokens that will be used across the platform. Below that is the Secure Access Gateway setup. Here, Service Foundry deploys Traefik as the external load balancer, integrated with OAuth2 Proxy. This ensures that only authenticated users can access the front-end and back-end services. When a user accesses sfapp.your-root-domain, the request flows through Traefik and OAuth2 Proxy, then reaches the React-based console front-end. Similarly, API requests go through sfapp.your-root-domain and are routed to the Go-based console backend. These load balance services provide a robust and secure entry point for all users interacting with the Service Foundry console. To access the Service Foundry console, you must configure a DNS record that maps the hostname sfapp.your-root-domain to your cluster's ingress IP or load balancer. This DNS setup ensures users can reach the console front-end securely and consistently. Once the DNS is in place, users are redirected to the Keycloak login page for authentication. Keycloak handles identity and access management for the console. During the bootstrap process, you can configure the initial admin account. By default, the username is DevOps, and the password can be set in the bootstrap configuration. This lets you sign in immediately after setup and begin managing your Service Foundry environment. This is the main dashboard of Service Foundry Console. At the top right corner, we can see the deployment job status, which shows when the last job started, when it completed, and its result. This job is a critical operation that ensures infrastructure and application components are deployed in a coordinated and consistent manner. To avoid conflicts or misconfigurations, only one instance of the deployment job is allowed to run at a time. Below the job status, we have a collection of quick link buttons designed specifically for DevOps engineers. These buttons allow users to rapidly perform essential tasks such as installing enterprise or open source apps, enabling EFS or S3 CSI drivers, managing persistent volumes, and configuring the SSO server, all with a single click. In the middle section of the dashboard, we can monitor the health and sync status of applications with intuitive gauge charts. These give us immediate visual feedback on how many applications are healthy and properly synced with Git. And most importantly, at the top right of the quick links, we have two powerful buttons: Enable Observability and Enable OBI. The first one installs a full observability stack, including metrics, logs, and traces collection. Once that is installed, the second button, Enable OBI, which stands for eBPF-based observability instrumentation, becomes available. With just one click, teams can bootstrap deep kernel-level observability without modifying the application code. The dashboard is thoughtfully designed to empower DevOps teams with visibility, control, and instant access to critical automation features across Kubernetes workloads. In the next video, we'll demonstrate how to enable the observability stack in just one click.